What's up, guys? My name is Mike. I am software engineer, algorithmic Forex trader, and I welcome you in this next episode of building the proper software for latency arbitrage algo trading, where I share my journey of building this kind of software. So if you are new to this channel, feel free to check out our previous episodes, the previous episodes that I made before, to see how the software was growing and was changing, and basically how we got to this stage where we are right now. And in this episode, I will show you what is the standard approach, the standard architecture of latency arbitrage algo trading systems that you can find on the market right now. And of course, I will show you how my system is different from all of them. So let's start from the beginning. If you are familiar, if you ever trade the latency arbitrage on Forex brokers, Forex exchanges, you basically used to set up something like this. You have a VPS, right? You need to rent a VPS to get the fastest data, the fastest speed of data, the fastest ping that you can get. So you need to get a fast VPS, and then inside this VPS, you are running usually your application, which is desktop application, right? And how you manage this application, you need to use remote desktop to actually connect to this VPS and to see the desktop interface, and then you can open the desktop app, which actually connects to the Forex brokers, let's say brokers, and submit trades for you. So basically here all the strategies and all the logic is running, right? So now, if you want to scale it out, let's say you are running one strategist, or you are running the operation on VPS based in London, but you also want to scale out your operations to New York data centers. So what you need to do, you need to get the second VPS, which is located in New York. And then, of course, you need to install again the same desktop application. And if you want to manage your operation on London or on New York, you need to also use remote desktop. So this setup is fine, it's okay, it's working. But what happens if you start adding more and more data centers? So imagine you get another VPS and another one, and another one. And now connecting to all of them using remote desktop and managing the trades and strategies in real time, especially when you have high volume and when you have, let's say, news, a lot of stuff is going on the market. Managing all of them at the same time is getting like pain in the ass, I would say. It's very unmanageable and unscalable. So now, how I solve this problem and what is my approach to managing the latency arbitrage operations by using my stack, my software. So let's delete all of them. Okay, and start again. So how I am doing this is that, again, I am renting a VPS in data centers, right? VPS London, and let's say I have VPS in New York. And now, instead of installing desktop application, I developed something called agent, HFT bridge agent. So this is basically a software that runs in the background of your operating system, and when it runs in the background, we also skip all the UI stuff. So actually, to run this agent on your VPS, you do not even need to have a desktop. You can have the operating system without desktop with only CLI. So we run agent script here, and agent here. And what this agent does, again, it basically does the same thing as all of those desktop applications. So we have the brokers, and we can connect to them through agent, submit trades, turn on, turn off strategies and stuff like this. But agent doesn't have any UI, any user interface. So how we can actually manipulate this? So guys, what happens when you start the agent? I developed another service called the Hub, Agent Hub, which is basically a server that is responsible for connecting all of the agents to one place. So when you start the agent sends the message to the hub that, hey, I just connected, I'm located in this IP, and you can manipulate me. And then the hub sends confirmation that, hey, I recognize this IP, I recognize this computer, and basically they open a WebSocket real-time communication. And they can send messages to each other. So basically agent can listen for the messages from hub for actions like open the trade, close the trade, start the strategy, close the strategy, connect to the Forex broker, disconnect, and stuff like this. So basically all the communication is being done by those WebSocket messages here. I use the Signal R technology to basically maintain all of the messages for me. So this hub is basically connecting all of those agents into one place. But then what happens later on? So hub receives the messages and forwards those messages to the RabbitMQ. RabbitMQ is basically an enterprise-grade message broker where you can send messages and listen on messages. It's something like publish and subscribe system. So basically, everything what happens on the agent is being forwarded through the hub and then to the RabbitMQ. And now, on RabbitMQ, we have loads of messages. RabbitMQ can receive messages and send messages. So then we created another system called the TS parser, which is responsible for managing all the time series database, the time series objects. So now imagine that you are running connections to few brokers on the agent, let's say on this agent and on this agent. So what happens? Basically, when you get new quote from the broker, then this quote is being sent to the agent. This quote is being sent to the agent, and then agent sends it to the hub, and then hub sends it to RabbitMQ. And in RabbitMQ, we have all the market data from all the agents. So then we have the service called TS parser, which actually listens on only market data or trades open, trade close data, and then it sends it to the time series database. We have the InfluxDB for this purpose. InfluxDB. And in InfluxDB, we store every single tick that happened on every single VPS. So later on, we can manage the history or see the live stream of data from all of the VPSs or on charts. Okay, guys, so we know what happens with the market data and trades, but how we can manage the agents. So we have another service called the agent state. And agent state listens on messages of type like start the connection, close the connection, connection was dropped, or market data subscribed, unsubscribed, new trade opened, sorry, not new trade, but basically it listens on all the actions that are happening on the agents that are not related to time series. So basically they're listening on messages that are related to the state. And then we have another database called Redis. Redis is basically a simple key value database which is optimized for high amount of reads and writes. Redis. And in Redis database we keep the state of all of those agents. So basically we have information about every single agent, the current state, so what brokers they're connected on, brokers, what strategies the agent is running, what market data the agent is subscribing to. So basically in Redis we keep all the information about the state of the agent. So imagine instead of viewing this information on your desktop application, we actually store everything in the Redis database, and we can see the state of what's going on in every single VPS, in every single agent. But now again, how we can manipulate this, how we can perform actions on the agents. So now we created one big API. Which is exposed to the network, and basically this API has access to our Redis database, it has access to our InfluxDB database, and also it listens on the RabbitMQ messages. So by using our API, we actually get access to all of the historical data on all of the agents. Basically every single time series that happened, we have access to it and we can fetch it. We can download it from database. We also have access to the Redis, so we have access to the state of every single agent, every single VPS that we are running our system on. And we also have the connection to the RabbitMQ. So we get the messages real time. And now how the communication works, what is the technology? So for RabbitMQ we used WebSockets to actually push data to the API, and for this we used REST, request response. So now guys, if you can see this this diagram, you can actually see the flow that we have one API, this one, to manage every single thing that happens in our HFT system. So we can manage everything from one data source. And now it starts to be interesting, because when you have one API, then we developed the UI. And by using the API, we could develop different kinds of user interfaces. So what we did, let me just push it a little bit up. So we created the iOS app, yes, app for the iPhone. For this one, I use the Avalonia framework, but basically we developed app that connects to the WebSocket and also use the REST request. And we can view every single thing on our iOS app, on our iPhones, basically what happens in our infrastructure. And then if we click on, let's say, start connection on VPS1 to this kind of broker, we just, click the button, and then the message is being sent to this API. Then this API sends message to the RabbitMQ. RabbitMQ sends message to the hub, and then hub sends message to the agent. Agent connects to the broker, and then again we have the response the same way. So basically the response goes through entire stack up, and we get the live information on the UI, if the agent is, if the connection is being established or not, what's the status, and the same thing with market data. Basically we can view everything. So we have the app and also the iPhone app, but also we developed the Next.js web UI, which is actually also real-time web application. So we have the Next.js stack. We used server rendering for this kind of purpose. So Next.js is using also our API, and is also using WebSocket messages and the REST messages. And then we are rendering the pages on the web. No, so I just draw a laptop like here. Maybe let's draw it like the just web browser. So now we have the app, and we can manage every single thing from the web UI. So we can view all of the agents, all of the VPSs, every single market data. We also integrated the TradingView charting platform to view the live quotes. So this is it, guys. I hope you enjoyed this kind of a live session where I just show you my architecture, how I developed everything, and basically what's the idea, what's the logic. Let me know in the comments if you're interested of moving your latency arbitrage operation to that kind of stuff, so you can actually manage everything from your iPhone app or from our web terminal. And again, in the next episode, I will show you basically each component, how it looks like and how it performs on the live data. So we are going forward and slowly approaching end of this project. So thank you for watching, and see you in the next video.